Ruminants are adept at utilizing fiber mainly because of the large reservoir that we call the rumen. Basically, it's a large fermentation vat that harbors a microbial population that's very complex. It consists of both bacteria, protozoa, fungi, all of which work together to digest the fiber that the animal consumes. The fermentation vat also acts to retain that fiber for a significant period of time. So when an animal consumes forage, it doesn't just immediately pass right from the rumen into the lower tract, because the microbes require time in order to colonize that fiber. They proliferate in numbers, they form complex communities that then work together to carry out the digestion of the fiber itself. Fiber digestion requires several different enzymes in order for it to achieve and liberate the glucose that is required by the microbes ultimately. And when we look at the efficiency of the rumen in terms of its ability to do that, it's currently the most efficient system that was known to mankind in terms of its ability to convert fiber-based feed sources into metabolic products that can be used by the animal directly. Well, a lot of the focus in North America, if we're talking about feeding animals in confinement, is around using fiber as what we call effective fiber to maintain rumen function. And basically, the ruminant animal evolved to utilize fiber. And the amount of digestive disturbances we would encounter on fiber-based diets is very low. So we add in fiber on grain-based diets to reduce the occurrence of digestive upsets that occur as a result of excessive acid production as a result of feeding grain and the liberation of glucose from starch, which occurs much more rapidly than it does from fiber. But at the same time, the forage is often overlooked as also being part of an energy source and a protein source within the diet as well. We need to basically recognize that. And because of the pressure that we're seeing, the growing pressure about the use of grains for animal feeds, is particular in ruminants because ruminants are so adept at digesting fiber, there's a pressure to increase the utilization of forage in ruminant diets. And if we're going to do that and maintain the same levels of production, then we need technologies that will enhance the derivation of the energy that's in that fiber to achieve the same levels of milk or meat production that we see today. There's lots of options that we can use to try to improve the utilization of fiber. Probably the majority, in the past has really focused around the whole plant breeding and selection processes. So if we look at, for example, if we take a forage source like lucerne, its ability, its feed value has improved over time. Some of that's related to the productivity, so the yield is often what we're selecting for when we're looking at improved forage varieties. But we also, in some cases, are looking at improvements in digestibility. Probably the most well-noted one is in the relation to corn silage when you're talking about the brown midrib selection, where they select it for lower lignin content. Lignin is one of the major factors that limits plant cell wall digestion. So anything you can do to lower the degree of lignification or the linkages between lignin, cellulose, and hemicellulose, then you can improve the digestibility of the fiber. So that's the plant side. We've even looked at using where we introduce enzymes that are expressed within the plant as a method of trying to further improve fiber digestion. That proved successful in the work we did. The challenge there is that you are basically creating a transgenic plant, and so consumer acceptance, producer acceptance of transgenics can be an issue if it's not adopted. The other factor that needs to be considered is you really can't afford to introduce any trait that compromises either the degree of disease resistance of the plant or the yield. Anything that's introduced like that will lower the overall profitability associated with the forage as well. So you need a balance between all of those factors as well. We've also for a long time used a lot of physical processing of the forage as a method of improving digestibility. So chopping or grinding or pelleting have been approaches used to improve fiber digestibility. The cow itself has its own mechanism through rumination and the amount of damage that's done during eating and that, which breaks up those plant cell walls and exposes surfaces to colonization by those microbes that I talked about. And then we can also look at chemical treatment of the forage as well. We know that a lot of the linkages between lignin and hemicellulose are based on ester or ether bonds. And so there are alkali treatments that we can use to try to break those bonds and make the hemicellulose more available to digestion by enzymes. And then the other area that we've been doing a lot of work in is using enzymes from other sources, which we would call exogenous enzymes, adding those into the diet as a method of complementing or acting synergistically with the enzymes that are naturally produced by the microbial population. And I think, as I'll show this afternoon, a lot of the methodologies we're using in that now are far more sophisticated than we were using 20 or 25 years ago, because we've had a lot of tools evolve in the molecular area that really lets us look at those interactions with a level of precision that was previously impossible.